In this video, we'll be discussing section 4.4 from chapter 4 of P3. Okay, and we'll be discussing, we'll be actually continuing a discussion for double angle formulae and addition formulae for our sine, cos, and tan ratios. And in this section, we'll be using this formulae. Okay, the three addition formulae from section 4.1 and three double angle formulae from section 4.3, and use them to solve equations and also simplify our expressions. Okay, so in the first question, the first example that you're going to do is question number 1c from exercise 40. Okay, so exercise 40, question number 1c, and this is on page 84. Okay, and the question we have is cos of theta plus 25 degrees, cos of theta plus 25 degrees plus sine of theta plus 65 degrees is equal to 1. Okay, cos of theta plus 25 degrees plus sine of theta plus 65 degrees is equal to 1, and our interval is 0 degrees is less than or equal to theta, which is less than or equal to, which is less than actually 360 degrees. Okay, less than 360 degrees. Always be careful with the range. Okay, so 0 is less than or equal to theta, which is less than 360 degrees. We have cos of theta plus 25 degrees plus sine of theta plus 65 degrees equals 1. And notice, okay, that we have a complex expression over here, a complicated expression over here, theta plus 25 degrees, and we have also sine of theta plus 25 degrees. Okay, it is not possible to combine both of this into a single trigonometric ratio. Okay, it is not possible to square them, because even if you square them, it is still going to have theta plus 25 in this one and theta plus 65 in this one. So the best option over here is to break down, okay, both these trigonometric ratios. Okay, and we'll be using our compound angle formulae to break down this so that you can get cos theta expressions and sine theta expressions, and from there we can calculate like terms. Okay, so let's first break down cos theta plus 25 degrees. That becomes, okay, cos theta cos 25 degrees minus sine theta sine 25 degrees. Then we have over here, for sine of theta plus 65 degrees, we have sine theta sine 25 degrees, sorry, cos 25 degrees plus cos theta sine 25 degrees, and then that is equal to 1. Okay, so cos theta cos 25 degrees minus sine theta sine 25 degrees, that's for the cos expression. Sine theta cos 25 degrees plus cos theta sine 25 degrees, that's for the second expression, and then that is equal to 1. Now let's collect our cos theta term together. Let's collect our sine theta and sine theta term together. You get cos theta into cos 25 degrees plus sine 25 degrees then you have plus sine theta into cos 25 degrees minus sine 25 degrees is equal to 1. Okay, so we have, excuse me, this was 65. Okay, so again we have cos theta into cos 25 degrees, okay, plus cos theta into sine 65 degrees. Over here you have sine theta into cos 65 degrees minus sine theta into sine 25 degrees. Okay, now from here, where do you go? Okay, we can, notice that we have cos, we have sine, okay, and had this one been 0, we could have easily transferred this to the other side and divided by cos theta. Okay, because if we divide by cos theta, you get tan theta. Okay, but the over here we still have an issue. If we try to divide all sides by cos theta, this cancels out, this becomes tan theta, but over here we still have a by cos theta remaining. In other words, we are not able to get rid of any of these expressions completely. Okay, over here the trick lies in figuring out that 25 and 65 do have some relationships with each other. Okay, 25 and 65 do have some relationships with each other, and by that we mean that 25 plus 65 degrees is equal to 90 degrees. Okay, so if you notice, Okay, this is the sine graph that is moving from 0 till 1, and this is the cos graph that is moving from 1 till 0. Okay, notice the sine graph and the cos graph are having a symmetry at theta equals 45 degrees. Okay, so let's talk about 25 degrees over here. Okay, whatever 25 has, okay, its ratios are going to be the same for 90 minus 25 degrees, but the other one is going to have the same value. Okay, so the other one is 90 minus 25 is 65 degrees. Okay, and sine of 25 degrees is going to be cos of 65 degrees, and cos of 25 degrees is going to be sine of 65 degrees. Okay, this is because of the symmetry of the cos sine graph at theta equals 45 degrees. So over here again, before I continue further, trying to solve these trigonometric equations and any kind of equations is basically trying to figure out this kind of patterns and finding out any way, okay, that you can simplify these equations. Okay, so over here as of now, okay, dividing by cos would not have worked out for us. Okay, it would not simplify anything for us. Okay, but note we do notice that 65 and 25 are basically adding up to 90 degrees. Okay, and we can use the relationship, we can use the sine cos reflection symmetry at theta equals 45 degrees. Okay, we can use that to find, we can deduce that sine 25 degrees and cos 65 degrees are the same, and cos 25 degrees and sine 25 degrees are the same. So since sine 25 degrees and cos 65 degrees are the same, this thing cancels out to 0. Okay, because cos 65 degrees and sine 25 degrees are the same. Okay, so this thing cancels out to 0, the entire term cancels out to 0, and thus we have cos theta into cos 25 degrees plus sine 65 degrees, and that is equal to 1. Okay, one thing more though. Okay, the question actually does not ask for finding the exact value, so actually you could use the calculator to find that this was 0, and that would have been easier, okay, to come down to this come to this stage. Okay, so cos theta equals this, we can simply transfer cos theta is equal to 1 by cos of 25 degrees plus sine of 65 degrees. Notice that cos 25 and sine 65 degrees are both the same thing. Okay, so it's I can excuse me, what am I writing? Okay, cos 25 and sine 65 are the same thing, so we have 1 by 2 cos 25 degrees. Okay, this you can use the calculator to find the answer. Okay, theta is therefore equal to cos inverse of this entire expression, and if you use the calculator, okay, you find that cos inverse of 1 by 2 cos 25 degrees is equal to 56.5 degrees to 1 decimal place. The question is asking for 1 decimal place, so it's 56.5 degrees. We are not done with the solution. We have 0 to 360 degrees. The second solution is going to be in the fourth quadrant, if you remember the HDC diagram. Okay, the second solution is going to be in the fourth quadrant, and that is going to be 360 minus this answer. So 360 minus the answer is going to be 303.5 degrees. Two answers to the solution. So again, okay, for the first step, okay, since we have theta plus 25 and theta plus 65, to help us solve this, we broke down, okay, both the complex compound angle ratios to simpler components, cos theta and sin theta, and from there we moved on to find the answer. Now let's solve from the same exercise 4D. Let's solve question number 5i. Okay, so question number 5i, and in question number 5i we have 2 tan theta is equal to root 3 into 1 minus tan theta into 1 plus tan theta. Okay, 2 tan theta equals root 3 into 1 minus tan theta into 1 plus tan theta, and 0 is less than equal to theta, which is less than equal to 2 pi. Alright, now Okay, we have tan theta, we have tan theta, we have tan theta, and therefore this should be easy to solve out. Okay, if you look on first glance, in your first glance, you'll be noticing that there's only tan theta in this equation, and therefore it should be easy, pretty easy to solve this equation out. Okay, so let's try to solve out, okay, by multiplying out the terms over here. Okay, this term is going to become 1 minus tan theta into 1 plus tan theta. That becomes 1 minus tan square theta, because that is, if you remember, a square minus b square is equal to a minus b into a plus b. Okay, so we have a minus b, a plus b, that is going to be a square minus b square, which is 1 square minus tan square theta. So 2 tan theta is equal to root 3 into 1 minus tan square theta. Okay, now we'll be doing two methods. The first method is just go on as usual. So this becomes root 3 minus root 3 tan square theta. Get everything out to the same side. You get root 3 tan square theta plus 2 tan theta minus root 3 is equal to 0. So root 3 tan square theta plus 2 tan theta minus root 3 is equal to 0. Okay, so this is our first, and in this step we are getting all the terms on the same side. Notice that this equation is a quadratic in tan theta. Okay, and let's use the quadratic formula to find the values for tan theta. So tan theta is going to be equal to minus b is going to be minus 2 plus minus root of b square, which is 4, minus 4ac, minus 4, a is root 3, c is minus root 3. So since we have minus root 3, I'll change the sign over here. So 4 times 3 divided by, we have 2 times 2a, that is 2 root 3. Okay, in other words, this is equal to minus 2 plus minus, this is 4 plus 12, which is 16. 16 root is going to give us 4. So minus 2 plus minus 4. Okay, minus 2 plus minus 4 divided by root 3, and sorry, 2 root 3. Okay, we have 2 in the denominator. You can factor 2 from the numerator. You get minus 1 plus minus 2 divided by root 3. Minus 1 plus minus 2 divided by root 3. Okay, in other words, we have In other words, we have 1 by root 3 and minus root 3. So these are two answers for tan theta. We are not done with the solution, because we need to find theta. Okay, so for the first solution, 1 by root 3. Okay, for a first solution 1 by root 3, the tan inverse of this value is going to be 30 degrees. But notice our range is given in radians, therefore we need to write the answer in radians. 30 degrees in radians is going to be pi by 6 radians. Okay, we do need to find a second solution, because our range is a complete period, 0 to 2 pi radians. Okay, and the second solution is going to be in the third quadrant, and that can be easily found by using pi plus theta. Because if you have theta, this second solution is going to be pi plus theta. Okay, so pi plus pi by 6 is going to be 7 pi by 6. Okay, for minus root 3, our first solution, okay, is going to be, first of all, let's talk about positive root 3. Positive root 3, we are going to have 60 degrees, or pi by 3. We have minus root 3, that is going to be minus pi by 3. Okay, so for minus root 3, we'll get minus pi by 3. Okay, because of the odd property of the tangent function. If tan of pi by 3 is root 3, tan of minus pi by 3 is minus root 3. But minus root pi by 3 is not in a range. Therefore, our first solution is going to be add 2 pi to this. That's the first solution. 2 pi minus pi by 3, that is going to give us 8 pi by 3. And a second solution, 8 pi by 3 is going to be in the fourth quadrant still. Okay, 8 pi by 3 is in the fourth quadrant. Our answer in the second quadrant, which you're still missing, is going to be minus pi. Okay, and that is going to be 8 pi by 3 minus pi, which is 2 pi by 3. Okay, so writing those answers down here, we have 2 pi by 3, 8 pi by 3. Okay, so 2 answers for the first one, 2 answers for the second. Now, this is the correct answer. On the other hand, we could have actually, should I say, dodged, okay, the quadratic equation procedure over here, because notice that instead, okay, so over here from this equation we moved on to this equation over here and we will solve the quadratic equation. Now instead of trying to solve the quadratic equation from here, let's take a different turn and use 2 tan theta divided by 1 minus tan square theta is equal to root 3. So I took 1 minus tan square theta and divided both sides by 1 minus tan square theta, you get this expression. And notice that this expression over here is actually your double angle formula relationship for tan. Or in other words, I can rewrite this, okay, as, okay, tan 2 theta is equal to root 3. Okay, tan 2 theta is equal to root 3. Tan 2 theta is equal to root 3. Okay, so since tan 2 theta is equal to root 3, our range is from 0 to 2 pi. So for 2 theta, our range is going to be from 0 till 4 pi. Okay, so this is the new range for 2 theta. From 0 to 2 pi, that changes from 0 to 4 pi for 2 theta. Let's solve the equation. We get 2 theta is equal to, for root 3, root 3 is the tangent ratio of 60 degrees. In radians, that is going to be pi by 3. The second solution is simply found by adding pi to this, okay, pi plus theta. So that is going to be 4 pi by 3. We have 0 till 4 pi as a range over here. So since our range, our boundaries are actually 2 periods, this was a single period, but for 2 theta it's 2 complete periods. We just need to add 2 pi to both of these answers to get the remaining 2 answers. So 2 pi to the first one, we get 7 pi by 3, and 2 pi to the next one, we get 10 pi by 3. Pi to the next one, you get 10 pi by 3. Okay, now let's divide both the answers by 2. Okay, we'll get pi by 6, 2 pi by 3, 7 pi by 6, and 5 pi by 3. Okay, this was actually 5 pi by 3. I did a calculation error over there, so this was 5 pi by 3. Now notice that in both these cases the answers are the same. Okay, in this procedure we did not use the double angle formula, and we used the quadratic equation to solve the answer, which is correct. There's nothing wrong in that. Okay, in this procedure we tried to notice the pattern, and we noticed that this thing is the same as the double angle relationship for tangent ratio, and thus we used that one and we get the answer over here. Okay, both the methods are correct. As long as you can get the answer, it does not matter which method you use, unless the question specifies the method that you should be using, in which case you should follow what the question says. Okay, now let's consider another example. In this example, will be from the same exercise for D, we'll be solving question number 13. Okay, now in this question they're asking us to use the identity sine square a plus cos square equals 1 to prove that sine raised to 4a plus cos raised to 4a is equivalent to half into 2 minus sine square a, sine square 2a, excuse me. Okay, 2 minus sine square 2a. So this is the identity that needs to be proven. Okay, and the question does give us a hint that we need to use the relationship sine square a plus cos square equals 1. Okay, this is the relationship that you need to use. Okay, so again, trying to solve this trigonometric identities is basically trying to figure out patterns and being able to understand exactly how the terms are moving from one side to the other. In this case, okay, we will be starting with squaring both sides of this equation. Okay, so let's take this equation. We are not starting from either the left hand side or the right hand side. We are starting from the identity itself, and we'll be squaring both sides of this identity. Okay, usually when you solve this kind of identities, you usually start from either the left or the right hand side. In this case, you're not starting from either of them. Okay, we are starting from our identity. Okay, now the question might be that, well, how do you know in the examination whether you should be using the left hand side, the right hand side, or a completely different identity? Okay, there's no simple answer to that question. The question might give you some hint as to how to work out the answer. Okay, if not, in that case, you need to be able to understand the pattern, figure out some pattern, okay, and figure out how you're going to work out yourself. In this case, you're going to square both sides. So sine square a plus cos square a the whole square is equal to 1 square. Okay, let's expand this bracket over here. We get sine square a the whole square, that is going to be sine raised to 4a, plus 2 sine square a cos square a, plus cos square a the whole square, which is cos raised to 4a, is equal to 1. Okay, we basically expand the bracket, you get this expression. Okay, now notice you have sine raised to 4a cos raised to 4 on the left hand side. Here you have 3 things on the left hand side. Let's take the excess thing to the other side. So sine raised to 4a plus cos raised to 4a is equivalent to 1 minus 2 sine square a cos square a. Okay, now notice you have sine square a cos square a, we have sine a cos a the whole square, and this sine a cos a the whole square, we can actually use our double angle formula relationship for sine. Okay, if you remember, the double angle formula relationship for sine is sine 2a is equal to 2 sine a cos a. Sine 2a is equal to 2 sine a cos a. Therefore, sine square 2a is going to be equal to 4 sine square a cos square a. Over here you have 2 sine square a cos square a. In other words, if I replace this by half into 4, I now have the exact expression for sine square 2a in this expression. Okay, so replace 4 sine square a cos square a with sine square 2a. Okay, last step, factorize half out of this expression. We get, if you factorize half out of this expression, 1 divided by half is 2, half divided by half is 1, or I can just leave it out, and that is equal to sine square 2a, and that's your right hand side. So this left hand side is therefore equal to your right hand side over here. Alright, now in part B, they're asking us to deduce that sine raised to 4a, okay, plus cos raised to 4a is equal, sine raised to 4a plus cos raised to 4a is equivalent to 1 by 4 into 3 plus 4 cos 4a. Okay, so 1 by 4 into 3 plus cos 4a. Okay, so we have sine raised to 4a plus cos raised to 4a equals 1 by 4 into 3 plus cos 4a. Now notice from a previous expression over here we have proven this, so we have this expression now. Okay, we can use this expression. Okay, since we've proven it, we can now use the expression, we can use this expression as a starting point. Okay, since this is already proven. Okay, notice that the left hand side sine raised to 4a plus cos raised to 4a and the left hand side over here are the same. So basically we do not have to do any changes on the left hand side. We need to make some changes on the right hand side. Okay, in the right hand side you have sine 2a, actually sine square 2a. On the left hand side you have cos 4a. Okay, so the relationship we're going to use is something that relates cos 4a with sine 2a. Okay, what is the double angle relationship for cos? The double angle relationship for cos, okay, is going to be as we discussed in a previous section videos. Okay, cos 2a is equal to cos square a minus sine square a, or 2 cos square a minus 1, or 1 minus 2 sine square a. Okay, so you have three different versions. Okay, cos square a minus sine square a, 2 cos square a minus 1, or 1 minus 2 sine square a. Now, which one are you going to prefer over here? We have cos 4a, which is the double angle version. We have sine 2a, which is the single angle version. So we want the cos double angle to be replaced with just the sine of the single angle. We do not want cos, so in that case we are not going to use the first one, we are not going to use the second one either. We are going to use the third one. Okay, 1 minus 2 sine square, because that is the only one that has got just sine. Okay, so cos 2a is equal to 1 minus 2 sine square a. Cos 4a is going to be equal to 1 minus 2 sine square 2a. Okay, again cos 4a is equal to 1 minus 2 sine square 2a. Rearranging this expression, we get, let's take cos 4a to that side, let's get that one to this side. We get 2 sine square 2a is equal to 1 minus cos 4a. Okay, and therefore sine square 2a is equal to 1 minus cos 4a the whole by 2. Okay, so let's start from the right hand side over here. We get, this is a question, left hand side does not change, so let's start from an expression on the right hand side. Right hand side, half into 2 minus sine square 2a is equal to, replacing the sine square 2a with this expression, we get half into 2 minus 1 minus cos 4a by 2, 1 minus cos 4a the whole by 2. Okay, let this stay in brackets so that you don't make any sign changes, sign mistakes because of this minus over here. Now let's expand the bracket, okay, and apply minus 1 to each of this separately. So we get, first let's multiply this one by both 2. So we have 1 currently on the denominator for this one. We're going to add the combine the fractions, so let's multiply both the numerator and the denominator by 2. Okay, now this one is 2, then this one is 2, we can easily combine them up, and you get half into 4 minus 1 minus cos 4a the whole by 2. Okay, rest we need to just expand the brackets. We get 1 by 2 into 2, 2 by 2, that is equal to 1 by 4. Okay, 4 minus 1 plus, okay, the minus changes the sign over here, 4 minus 1 plus cos 4a, that is going to be equal to 3 plus cos 4a, and that is our expression in the question for the right hand side. Okay, so 1 by 4 into 3 plus cos 4a, that is the expression for sin raised to 4a plus cos raised to 4a. Now in part C, they are asking us to solve the equation 8 sin raised to 4 theta plus 8 cos raised to 4 theta is equal to 7 for 0 is less than theta, which is less than pi. Okay, so 8 sin raised to 4 theta plus 8 cos raised to 4 theta equals 7, 0 is less than theta, which is less than pi. Okay, now since we solved part A and part B, okay, since we solved part A and part B, this part is definitely related to the previous part. In the previous part we had sin raised to 4a plus cos raised to 4a equals this expression. Over here you have 8 sin raised to 4 theta plus 8 cos raised to 4 theta, which is not exactly this expression, but the thing is, if we factorize 8 out, in that case we can get this expression in an equation. So let's factorize 8 out. We get sin raised to 4 theta plus cos raised to 4 theta, that is equal to 7. Okay, and sin raised to 4 theta plus cos raised to 4 theta is exactly this expression over here. Okay, again, sin raised to 4 theta plus cos raised to 4 theta is exactly this expression over here. Okay, so we are going to just replace with this expression in over here. We get 8 into 1 by 4, 3 plus cos 4a is equal to 7. So we replaced with our expression from the previous part over here. The rest is going to be simply simplification over here. 8 by 4, that becomes 2. 2 multiplied throughout becomes 6 plus 2 cos 4a is equal to 7. Take 6 to the other side, this becomes 1. Okay, take 2 to the other side, this becomes half. So therefore we have cos 4a is equal to half. Now, actually this was theta, excuse me. Okay, so cos 4 theta is equal to half. Now what is 4 theta? 4 theta is equal to the 4 theta is equal to the inverse cos of half. Okay, and half is the cosine ratio for 30 degrees. Excuse me, half is the cosine ratio for 60 degrees, which over here, since you have the answer in radians, this is going to be pi by 3. Okay, now we have 4 theta. The range is for theta only, so let's get a new range. The new range is going to be 0 is less than 4 theta, which is less than 4 pi. In other words, we have two complete periods. Okay, 0 is less than 4 theta, which is less than 4 pi. You have two complete periods. So that's why we have found the first answer, pi by 3. The second answer, if you remember the ASTC diagram, the second answer is going to be in the fourth quadrant. Okay, if you have theta, the second answer is going to be 2 pi minus theta. So 2 pi minus this answer is going to be 5 pi by 3. We get two answers. The rest is going to be simply add 2 pi to both of this. So 2 pi to the first answer, you get 7 pi by 3. And 2 pi to the second answer, you get 11 pi by 3. So that's for 4 theta. Our final answer, theta, is therefore equal to, divide all the answers by 4, we get pi by 12, 5 pi by 12, 7 pi by 12, 11 pi by 12. That's our answer. Okay, again repeating what we did in this question, we had 8 sin raised to 4 theta plus 8 cos raised to 4 theta. Our previous part had sin raised to 4a plus cos raised to 4a. So basically factorize 8 and then we substitute the expression from part B over here, and then the rest is going to be solving the trigonometric equation as we solve, as is usually solving P2.